In this problem, I can solve this one of two ways. I have a radical, so I can isolate it and solve, or I recognize that my smaller power is half the power of my other, so this does fit quadratic type. So I can use u substitution. If I let u equal that smaller power root x, and that would mean my u squared would be x, I could substitute in 6u squared minus 7u minus 3 is equal to 0. And I can solve by factoring. So if I take my leading coefficient times my constant and get negative 18, two factors of negative 18 whose sum is negative 7 is negative 9 and positive 2. So if I rewrite my middle term as those, drop my first and last terms down, and factor by grouping, I can remove a 3u from the first pair of terms, leaving a 2u minus 3. From the second pair of terms, I can't remove anything, so I'll write a plus 1, leaving 2u minus 3. My common binomial factor of 2u minus 3 comes out. My remaining factors of 3u and plus 1 form the terms of my other binomial. Therefore, my two values for u is the opposite of my constant, positive 3, over my leading coefficient 2. And in the other factor, the opposite of my constant is negative 1 divided by my leading coefficient 3. So I can substitute back in, root x is equal to 3 halves, square both sides to solve for x. 3 squared is 9, 2 squared is 4. And then in the right side, root x equals negative 1/3. I can see right here this is not going to work because the square root can't equal a negative. So that's extraneous, and my answer would be 9/4. I could have also solved this by isolating my radical. So if I have my 6x and negative 3 stay on the left side, and I add 7 root x to the right, once I isolate my radical, I can square both sides to get rid of it. When I square this binomial, I get 36x squared. Double the product of these terms. 6x times negative 3 is negative 18x. Double that gives me negative 36x, and my last term squared. Negative 3 squared is plus 9. That's all going to equal 7 squared, 49 times root x squared x. So as I continue to solve this, I'll move all the terms over. If I subtract 49x from both sides, I get 36 minus 49, which is negative 36 minus 49, which is negative 85x plus 9 equals 0. And so in solving for this, so when I look at these, I have a number of different combinations to look at. I'm going to go ahead and try ones that I anticipate will work. The product of the first terms has to be 36x squared, so it can be 9x and 4x. In here, I know that my last terms have to have a product of positive 9. Since they're positive, the signs are the same, and since the outer plus inner is a negative, I know those signs will be negatives. 85 is a large number, so I'm going to go ahead and put a 9 here and a 1 here, and when I do that, my outers are a product of negative 81 minus another 4x gives me a total of negative 85x. So these are my solutions. So if I solve, x is equal to 1 over 9 and x is equal to 9 over 4. What I would need to do is go back into the original form and test it. 6 times 1/9 minus 7 times the square root of 1/9, which is 1/3, minus 3, we want to test, is that equal to 0? And you can see right here, as I set this up, 1/3 times 7. If we put these all in terms of ninths, negative 7 is 21 ninths, and negative 3 is 27 ninths. So when you look at this, 6 minus 21 minus 27 does not equal 0. This is an extraneous solution. Do the same thing with 9/4. We have 6 times 9/4 minus 7 times the square root of 9/4, which is 3 halves, minus 3, and test, is that equal to 0? When we test that here, 2 goes into 4 twice, 2 goes into 6 3 times, so we have 27 halves minus 21 halves minus, and 3 is 6 halves, and that does equal 0. So we see that 9/4 will work.